Welcome to Spring LIB.
Okay, we are starting with acetylene, and our first reaction is with sodium amide, which we know would deprotonate our acetylene and give us an acetylide ion. Okay, which in the second portion of this first reaction, basically we are reacting then with a bromoalkane. Okay, so we expect then a SN2 reaction, kicking off the bromine, giving us now our no longer acetylene, our alkyne, right? With now this sort of cyclobutane attached. Okay, again, we're going to react it with sodium amide, which will now deprotonate the other side of the alkyne to give us, again, an alkynyl anion. Oops. Okay, and then in the fourth step, we're reacting this with this sort of tert-butyl, tert-pentyl bromide. Which again, SN2 reaction, kicks off the bromine. And we get our final product. Like so. Okay, now which of these does this match? Some of them are missing carbons. I think that's the main issue. But 4 is precisely what that matches. And so if tracking the carbons is maybe the hard part, I would just recommend, numbering them like, okay, this is carbon A, B, right? So then when I consider the products, I know I should have the 2 carbons that make up the double bond, and then I should still have A and B, right? And the same thing applies over here. I'm going to call the carbon that has the bromine on it, let's call it C, and the one with the tert-butyl on it, D. And I know after the reaction's over, I should have a bond between this carbon here, which was the anionic side of my alkyne. I should have a bond between the end of that triple bond to carbon C, and that should be bond to carbon D. Just to make sure I didn't lose any carbons, because I noticed some of the options are like the same thing, but with missing carbons, like so.